Okay, so let's start with a new tutorial and on a new topic, that is AWS Data Pipeline. So before we discuss AWS Data Pipeline, let us try to understand what is data pipeline. So a data pipeline is a series of processing steps to prepare enterprise data for analysis. Organizations have a large volume of data from various sources like applications, Internet of Things, devices, and other digital channels. However, raw data is useless. It must be moved, sorted, filtered, reformatted, and analyzed for business intelligence. A data pipeline includes various technologies to verify, summarize, and find patterns in data to take a well informed business decisions. Well organized data pipelines support various big data projects such as data visualization, exploratory data analysis, and machine learning tasks. What are the benefits of a data lines? After all, we must be clear as to why should we use data pipeline. So data pipelines let you integrate data from different sources and transform it in for analysis. They remove data silos and make your data analytics more reliable and accurate. Here are some key benefits of a data pipeline. First one is improved data quality. Data pipelines clean and refine raw data, improving its usefulness for end users. They standardize formats for fields like dates, phone numbers, while checking for input errors. They also remove redundancies and ensure consistent data quality across the organization. Efficient data processing. Data engineers have to perform many repetitive tasks while transforming and loading data. Data pipelines allow them to automate data transformation tasks and focus instead on finding the best business insights. Data pipelines also help data engineers more quickly process raw data that lost value from over time. Comprehensive data integration. A data pipeline abstracts data transformation functions to integrate the data sets from disparate sources. It can cross check values of the same data from multiple sources and fix inconsistencies. For example, imagine that the same customer makes a purchases from your e-commerce platform and your digital service. However, they misspell their names in the digital service. The pipeline can fix this inconsistency before sending the data for analytics. How does a data pipeline work? Just like a water pipeline removes or moves the water from reservoir to your taps, a data pipeline moves data from the collection point to storage. A data pipeline extracts data from a source, makes changes, then saves it in a specific destination. We explain the critical components of data pipeline architecture below. Data sources. Data source can be an application, a device, or another database. Disparate sources may push data into pipeline. A pipeline may also extract data points using an API call, webhook, or data duplication process. You can synchronize data extraction for real-time processing for collection data in scheduled intervals from your data sources. Transformations. A raw data flows through the pipeline. It changes to become more useful for business intelligence. Transformations are operations such as sorting, reformatting, deduplication, verification, and validation that change data. Your pipeline can filter, summarize, or process data to meet your analysis requirements. Dependencies. As changes happen sequentially, specific dependencies may exist that reduce the speed of moving data in the pipeline. There are two main types of dependencies: technical and business. For example, if the pipeline has to wait for central queue to fill up before proceeding, it is technical dependency. Conversely, if the pipeline has to pursue pause until another business until a unit cross verifies the data, it's a business dependency. Destinations. The endpoint of your data pipeline can be data warehouse, data lake, or another business intelligence or data analysis application. Sometimes the destination is also called a data sink. What are the types of data pipelines? There are two main types of data pipelines: stream processing pipelines and batch processing pipelines. Stream processing pipelines, number one, that is a data stream is a continuous increment sequence of small sized data packets. It usually represents a series of events occurring over a given period. For example, a data stream could show sensor data containing measurements over the last hour. A single action, like a financial transaction, can also be called an event. Streaming pipelines process a series of events for real time analytics. Streaming data requires low latency and high fault tolerance. Your data pipeline should be able to process data even if some data packets are lost or arrive on a different order than expected. Batch processing pipelines. Batch processing data pipelines process and store data in large volumes or batches. They are suitable for occasional high value volume tasks like monthly accounting. The data pipeline contains a series of sequenced commands, and every command is run on the entire batch of data. The data pipeline gives the output of one command as the input of the following command. After all data transformations are complete, the pipeline loads the entire batch into a cloud, data warehouse, or another similar data store. Difference between batch and streaming data pipelines. Batch processing pipelines run infrequently and typically during off-peak hours. They require high computing power for short period when they run. In contrast, stream processing pipelines run continuously but require low computing power. Instead, they need reliable low latency network connections. So we have seen that a data pipeline is a systematic and automated process for the efficient and reliable movement, transformation and management of data from one point to another within a computing environment. It plays a crucial role in modern data driven organization by enabling the seamless flow of information across various stages of data processing. A data pipeline consists of a series of data processing steps. If the data is not currently loaded into the data platform, then it is ingested at the beginning of the pipeline. Then there are a series of steps in which each step delivers an output that is the input for the next step. This continues until the pipeline is complete. In some cases, independent steps may be run in parallel. Data pipelines consist of three key elements: a source, a processing step or steps, and a destination. In some data pipelines, the destination may be called a sink. Data pipelines enable the flow of data from an application to a data warehouse, from a data lake to an analytics database, or into a payment processing system. For example, data pipelines also may have the same source and sink, such that the pipeline is purely about modifying the data set. Any time data is processed between point A and point B, or points B, C, and D, there is a data pipeline between those points. As organizations look to build applications with small code bases that serve a very specific purpose, these types of applications are called microservices. They are moving between more and more applications, making the efficiency of data pipelines a critical consideration in their planning and development. Data generated in one source system or application may feed multiple data pipelines, and those pipelines may have multiple other pipelines or applications that are dependent on their outputs. Big data pipeline. It is important to understand that is big data, particularly with reference to data pipeline. As the volume, variety, and velocity of data have dramatically grown in recent years, architects and developers have had to adapt a big data. The term big data implies that there is a huge volume to, to deal with. This volume of data can open opportunities for use cases such as predictive analytics, real time reporting, and alerting, among many examples. Like many components of data architecture, data pipelines have evolved to support big data. Big data pipelines are data pipelines built to accommodate one or more of the three traits of big data. The velocity of big data makes it appealing to build streaming data pipelines for big data. Then data can be captured and processed in real time, do some action, and can they occur. The volume of big data requires that data pipelines must be scalable. As the volume can be variable over time, with time it is most likely that the data will become big and then make big data events occur simultaneously or very close together. So the big data pipeline must be able to scale to the process significant volumes of data concurrently. The variety of big data requires that big data pipelines be able to recognize and process data in some different formats: structured, unstructured, and semi structured. Benefits of data pipeline: efficiency. Data pipelines automate the flow of data, reducing manual intervention and minimizing the risk of errors. This enhances overall efficiency in data processing workflows. Real time insights: with the ability of processes data in real time, data pipelines empower organizations to derive insights quickly and make informed decisions on the fly. Scalability. Scalable architects Architectures in data pipeline allow organizations to handle growing volumes of data without compromising performance, ensuring adaptability to change business needs. Data quality. By incorporating data cleansing and transformation steps, data pipeline contribute to maintaining high data quality standards, ensuring that the formation or information being processed is accurate and reliable. Cost effectiveness. Automation and optimization of data processing workflows result in cost savings by reducing manual labor, minimizing errors, and optimizing resource utilization. How data pipelines work. A typical data pipeline involves several key stages. Ingestion. Data is collected from various sources and ingested into pipeline. This can include structured and unstructured data from databases, logs, APIs, and other sources. Processing. The ingested data undergoes processing, which may involve transformation, cleansing, aggregation, and other operations to prepare it for analysis or storage. Storage. Processed data is stored in a suitable data store, such as database, data warehouse, or cloud storage, depending on the requirement of the organization. Analysis. Analytical tools and algorithms were applied to the stored data to extract meaningful insights, patterns, and trends. Visualization. The results of the analysis are presented in the visual format through dashboard or reports, making it easier for stakeholders to interpret and act upon the information. Data pipeline architecture. A robust data pipeline architecture is essential for ensuring the effectiveness of scalability of the pipeline. Common components include data source, the origin of data, which it could be databases, external APIs, logs, or other repositories. Data processing engine, the core component responsible for transforming and manipulating the data according to predefined rules and logic. Data storage, where the processed data is stored, ranging from traditional databases to fast data stores to hybrid cloud based solutions. Data orchestration, the mechanism that coordinates the flow of data through the pipeline, ensuring that each step is executed in the correct sequence. Data monitoring and management, tools and processes for monitoring the health and performance of the data pipeline as well as managing errors and exceptions. Data pipeline versus ETL. ETL refers to the specific type of data pipeline. ETL stands for extract, transform, and load. It is the process of moving data from a source, such as an application, to a destination, usually a data warehouse. Extract refers to the pulling data out of a source. Transform is about modifying the data so that it can be loaded into the destination, and load is about inserting the data into the destination. ETL has historically been used for batch workloads, especially on a large scale. But a new breed of streaming ETL tools are emerging as part of the pipeline for real time streaming even data. While data pipelines and extract, transform, load processes share similarities, there are key differences. Scope. Data pipelines encompass a broader range of data processing tasks beyond traditional ETL, including real time data streaming and continuous processing. Latency. ETL processes often operate in batch mode with a high latency that may not be suitable for real time requirements. Data pipelines, especially those designed for streamlining data, provide such much lower latency processing. Flexibility. Data pipelines are more flexible and adaptable to changing data processing needs, making them suitable for dynamic and evolving business environments. Data pipeline considerations. Data security. Ensuring the security and privacy of sensitive data throughout the pipeline is crucial to compliance with regulations and protecting organizational assets. Scalability. The architecture should be designed to scale horizontally or vertically to accommodate growing data volumes and processing demands. Fault tolerance. Building in mechanisms to handle failures and errors gracefully is essential for maintaining the reliability of the pipeline. Meta management. Effective meta management, the metadata management is crucial for tracking the lineage and quality of data as it moves through the pipeline. Performance. While there are use cases such as batch processing with relatively long processing windows, many times a data pipeline feeds mission critical and time sensitive operations such as payment, processing, or fraud detection. In those cases, fast performance and low latency are critical for the businesses to meet their required service level agreements (SLAs). Data pipeline architecture. Examples are data pipelines may be architected in several different ways. One common example is a batch based data pipeline. In that example, you may have an application such as point of sale system that generates a large volume of data points that you may need to push to a data warehouse and an analytics database. Here is an example of what that would look like. Thank you.